Hello, everyone. Let's take a look at devices and device drivers. They've actually got some really good information that probably should be in a hardware class, but you do see it in Windows, and that's where the importance is. The main thing that I want to make sure we start off on the right foot here and realize that device drivers, they're the piece of software that drives the device. So a device is just a general term that means anything like this video camera I'm using here, or the microphone I'm using over here. Those are devices. And those two devices are plugged into USB, right? You plug them in and then it goes through and sets them up. When it's setting them up, that's the device driver. That's the software that'll make sure you can use what's right in front of you. Now, if it's a very generic piece of hardware, like a mouse or even this camera is a pretty generic piece of hardware, and the microphone is too, it'll all be built in. The Windows will just go through, or Mac OS or Linux, it'll just go through and go boom, 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 boom. It's set up. But again, in that process, it recognizes it because it's plug and play and says, hey, what are you? The hardware with inside the camera, if we're using that as an example, says, I'm a Logitech and I'm an HD 1080p camera, blah, 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 blah. Now, another thing that's happening in here, and we look at this concept in a minute, is what resources do you need, right? So USB, you have basically a chip in there that's controlling all that. And so when that camera communicates to the USB, it's basically the USB is like, hey, what do you need? And you know what? It's not even that complicated because the camera already knows what it needs. And it basically says, this is what I need. Still up to USB to give it to it. It's up to USB to control it and figure out when it gets to do that and when it doesn't do that. All that's happening within the USB control chips and the bus. And so the camera itself has said, hey, this is who I am. This is the resources I need. And then that device driver, which is the software, has all that set up. And that's really how it works. Usually I will have some students at this point in class say, oh yeah, it was so easy to set up my, girlfriend's printer or my grandpa's printer, or usually it's a printer. But it's so easy to set this up. I just plugged it in and it just worked. Well, the one thing you need to know about device drivers is that there are particular ones. So you have to decide, do I keep the generic driver that Windows just loaded, or do I get the driver from the manufacturer's site? And that's downloading the software. As a matter of fact, for instance, if you're setting up a printer that's got, they've got a lot of options on printers and they're not all the same. And so what'll happen is if you look in the instructions, this is usually what I hear from a student. I didn't even have to follow the instructions. If you look in the instructions, it will tell you, don't plug this in. Go out to our website and download this. What it's saying is, hey, we don't want Windows setting this up. What we want you to do is we want you to go out to our website, download the appropriate drivers for this camera, for this printer. Usually it's something sophisticated like a printer. Go and download that and go through the install process. So once you download it, right, you double click it, you want to install this, yes, and it's very quick. And the reason why it's very quick is because it's really just the drivers. The times that get confusing, just to throw some real world stuff at you, you go out to HP, right? And there's, oh, I just want the drivers. Oh, and I want all this other software. I usually don't get all the other software. Most of the time, people really get fed up with that stuff. It doesn't work the way they want it to, and it's a lot of bloat. And for instance, in HP's example, you'll start getting pop-ups. Hey, you should buy some more ink from us, that kind of thing. And so usually just the driver is what you want off of their website. You click it, it installs and says, I'm done. Now you plug into the USB into the computer. And instead of grabbing the Microsoft stuff that's just, preloaded and maybe just be general for thousands of different types of printers, it will grab the correct HP stuff and load that in, and you're all set to go. They want you to do it that way because sometimes it can be difficult to back out the Microsoft stuff. So instead of plugging it in and going, oh, that Microsoft driver is not the one I want, let me go get the HP one, sometimes that will complicate things. And so they want you to do it from the get-go. So just remember the device driver is a piece of software, but it's coded. They wrote it especially for that piece of hardware. That's why sometimes people get a big gaming mouse. Yeah, you can plug that in and just use it like a regular mouse. But all the 18,000 buttons that you have on it are not going to work correctly because it's just loading up a HID compliant mouse. You would have to install the device driver that knows it's got 18,000 buttons on there and an LED bar, and now it'll see it. Right? That's the importance of those device drivers. Now let's take a look at, I've got it shared here. IO device communication strategies. So this is a really cool part that really talks about when you have a network card, how is that data getting in and out of there, which I think is cool. I geek out about that stuff. So they're defining some terms here so you'll know this is what's happening way down low. And this is what those device drivers are having to set up and talk to and make sure are correct. So a register is a storage location associated with an input-output device that the data can be read from and written to. So what that's basically saying is if somebody says it's a register, they're really talking about a special location within the system someplace, normally embedded on the card. But again, it's a network adapter built into your system these days. And basically, it's associated with that particular network card, that IO device, meaning it knows automatically it could send data to that register and nobody else is going to mess with it. It's its own. The IO controller reads the commands written to the control register and performs the requested action. So that's why that register is important, because it's going to stick commands in there and it's going to go, okay, now it's time to start the communications on this line or whatever it happens to be. The control register is where the device driver writes commands such as read or write for the IO controller to act upon. So the control register is where the device driver writes. So the software is reading and writing to that. Now we're making a link between the hardware and what's happening in the OS. And then a data register is where the device driver writes data that the device is outputting. This is particular then in the network card situation. We're dealing with a register that's dealing with IO control commands, and it also has registers where it's going to stick the data. So not the commands, but this is the data that I'm sending to the internet or receiving from the internet or from the LAN. A status register might indicate to the device driver whether the device is ready or not. We never did think about that. When you go in there and it says, hey, your printer's ready. Where's that coming from, right? It's coming way down there. So this device driver is making a good use of linking the hardware to the OS. Most control and data registers are a byte or a word in length, meaning 8 bits or 2 to 4 bytes for a word in length. And then in some cases, the register might be supplemented by a first in, first out chip or a FIFO chip, in which multiple bytes or words or input or output data are stored in the order that they are received. Now, lots of those communications devices, shouldn't say communications devices, lots of the devices that you plug in don't need it. Communications devices do need it. So when we use networking cards as an example, this is going to speed up the process. I have someplace as the operating system to put data, even if the IO port's not ready. So I can put it there. That's faster. Same thing in reverse. I'm receiving all this data online, and for some reason, the OS is a little busy, and we're talking milliseconds here, right? So I'll put this in the FIFO chip, and then, the device driver and Windows will take care of this. That's how they get it done. All right, so port mapped versus memory mapped. Port map IO uses a dedicated memory address referred to as a port, and I'll show you an example of that. And a special CPU instructions to communicate with those IO devices. Now, this is old school. This is basically like saying, hey, this is how we used to get it done. So if I wanted to print something, the CPU would have special instructions to talk to the printer, and it would use an IO port, an input-output port for that. So it's basically, the CPU is communicating with a lot of things internally. In particular, this one's a printer. It needs IO, input and output, and that's what that would do, port mapped. With memory mapped, the control and the data registers are mapped to the computer's main memory space, and the CPU uses the same instructions for reading and writing IO registers that it does for reading and writing RAM. So in other words, we got to a point, that's historically what's going on. We got to the point where they only really created like 4 of these, and we have a lot of more input and output that's going on, and we're beyond that. So we can go ahead and map that to memory and just, use it like it's normal memory. Get beyond that limitation. I want to cover DMA on this. You can look at programmed IO, but direct memory access is basically a device that really needs some speed. It really needs to be able to get around having to talk to the CPU in order to write something to RAM. And now if you think about that process, what it used to be was if you had an audio card, we'll say, audio's coming in and it has to say, hey, CPU, can I write this to RAM? Or even in the older days, hey, CPU, can you write this to RAM? And that bogs down the process of getting that audio in and out, and really was a big problem. Audio and video were a huge issue. If you got to always talk to the CPU, you'd have to have a really fast CPU to play some of the most simple games, because it was always involved in moving this around. So it wasn't very long before they said, hey, you know what we could do is set up some direct memory access, some DMA channels. We'll just program that into the system so that that product that's using the DMA channel, like audio, it doesn't have to talk to the CPU. It doesn't have to get permission. It doesn't have to send anything to it. It can directly access what's in that RAM. So that became a very, very important thing. All right, so I want to show you, they organize it into the following areas and all that stuff, which is good. But I want to show you, I'm going to go into Device Manager. So I'm just going to right click this, and Computer Management will show it. Disk Management will not, but Device Manager will take us there. So let me expand this. I know that this is small, and so it's probably not super easy to see. Have been in here, it's showing me what my computer name is, and then it's showing me all the devices on the system and everything that's on the system. So if you have a question mark in here, then that means it's like, hey, there's some kind of hardware device, but I don't know what to do with it. Right, so that's what a question mark will mean. But let's take a look at if I can see this. There's our storage controllers. Microsoft NVMe. There's our firmware. It tells us what our firmware is, which is really cool. That is not often populated there. It depends on the computer. Shows processors, and it's showing the threads, right? Not the actual core. And I am not finding it. So let me pause this while I go down the list so I can find this. I could just pull up network adapters, but let me see if I can find it first. All right, well, I didn't find exactly what I was looking for, but I figured, you know what, as I said, networking should have it. So what I looked at here is this killer E2600 gigabit Ethernet controller. That's actually the physical network jack on this computer. And it always comes up to general. So this is what we would see if we right-clicked on it or double-clicked on it. There it is, general. So I went to the resources, and notice it's got an IO range on there. So the input-output range is this 2F00 to 2FFF. That's actually a memory range that it's been given. And then you'll also see some more memory ranges that are not IO. Right, they're not the same. So this is the memory addressed version, right? So it needs more, is what it's saying. I need more space than what I thought. So I'm going to take up some more memory. This is where I'm going to put it. And then there's actually an interrupt request that's there. That these days, that's 59, interrupt request 59. Now, other things that you can see on this, you can see the driver. So you can see when the driver is given to you. You can update the driver from here and search for that, or go out and get it. But this normally happens through your provider. So I actually have the Acer software here, and it will just tell me, hey, you got an update for that. Or I could go out to their website and do it. Or I could wait for it to get published through Microsoft and finally have it through that way as well. You can disable the device, and you can even uninstall it. Now, uninstalling usually doesn't do much good if it's plug and play, which this is, because I will uninstall it and then it will reinstall it the next time it starts. So if you're looking like I need to permanently deactivate this, then just disable the device. But yeah, there's a lot of different things. For instance, this is the network control. This is a really good network card. So it actually shows me that I can disable, enable flow control. And a lot of this, right, you're like, I don't know what that is, but some of this you would learn in networking. Other things you wouldn't be even messing with unless you were trying to fix something that wasn't working for you. And so, but you can see if it's enabled or disabled. So this is accessing the settings of that special software for this particular card. And again, I could delete this, go and find those files and delete them. And I'm sure what would happen is Microsoft would just install some generic driver that wouldn't allow me to have control over all of that stuff, because that's going to be particular to the piece of hardware, and the driver software needs to know how to deal with that in particular. But that's what Device Manager does for you. It lets you see everything that's working. It lets you see all the settings that you can update things from there. These days, we don't use that tool as much, but definitely if you're troubleshooting somebody's computer, you probably will have to do that. So this is just getting you to see it, right? Just introducing you to it.